Okay, let's make sure I am actually recording. Okay, perfect. All right, so this section is devoted to everything with about graphing lines. And it's one of those things that you've seen probably numerous times throughout your high school and potentially college career. The notion of a slope and a y-intercept and slope-intercept form, that sort of thing. Right, so this we're not going to spend oodles of time on, hoping that it kind of is a quick refresher of what you've seen before. All right, so for one, associated with every non-vertical line is a quantity called its slope, right? So it's a way of measuring the steepness of a line. And basically the definition is if you have 2 points on the line, the slope is going to be the change in the y over the change in the x. So you literally subtract the y coordinates, often called the rise, and subtract the x coordinates, often called the run, and you divide those two. Right, the reason you can't have these on a vertical line is that the x coordinates would be the same, and so you'd be dividing by 0, right? So there is no such thing as a slope in the case of a vertical line. All right, so for these examples here, all we have to do, in each case, notice we have 2 graphed lines, and we want to determine their slopes, right? So all you have to do is identify the x1, the y1, the x2, the y2 in the picture, right? Either point can serve as either of these two. It doesn't matter. The only thing you have to remember here is that you have to subtract the y's and the x's in the same order, right? So notice here, I'm subtracting that y coordinate minus that y coordinate to get the top. So I have to divide by the difference being, so I need to divide the difference in the x's would have to be 3 minus a negative x. I cannot subtract one way for the y's and the other way for the x's, because if you do that, you're just going to get a negative of the correct slope, right? So it's going to be the opposite direction that you want. And so if I do that in this case, notice that I get just 11/9 for the slope. Similarly here, you subtract the y's and then the x's. Notice in this case, I'm using this as the y1, so not -9 minus 0 over -1 minus a -10. If I do that, I get a -1. Slopes with lines with negative slopes will be slanting downward, so they'll be falling per se. Lines with positive slopes will be climbing from left to right. All right, we addressed that. All right. Now the critical thing, remember what they always tell you is that no matter what 2 points you take on a line, if you compute the slope between those points, you get the same number back. And so in that way, a slope actually characterizes a particular line, right? So here we have 3 points that are labeled on the line. And what the goal of this example is to compute the slopes using all 3 pairs of these points and showing that no matter which pair you chose, you always got the same slope back, right? And so you can check through that, but in fact, that's always the case for a line. A line is a curve with constant slope, constant rate of change. And so you'll always, doesn't matter what point you choose, you'll always get that same measure of its steepness. All right, so y equals mx plus b form, that's called the slope-intercept form. The m is the slope, that's what we gave the definition of slope earlier, and b is the y value of the y-intercept. All right, and so for example, if you look at these lines just in comparison, you can kind of tell what each of these pieces are. So this line has a very steep in the negative direction and it crosses at the origin. So the b is 0, and the slope you'd expect to be a fairly large negative number, and it is, a negative 10x. Here, much less steep, right? It crossed, if you were to count those units, if you have the time and patience to do that, you'll find that we're 10 units down on the y-axis, and we are also 10 units to the left on the x. And so you can literally compute the slope by just using those 2 points. You'll get it to be -1. So your m is -1, and the y-intercept here is the y value where it crosses that axis. That's -10. Same thing here. This is even less steep than that. You have a slope of 3/4, which you can do if you were able to zoom in here. You can literally find 2 points for which lie on the line, and you can compute that. And you can see kind of that it crosses at -1. So it makes sense that the b would be -1, and the slope would be something smaller than 1. All right. So we talked about that. Let's actually, go ahead. I don't want you to see that yet. So given the fact that the equation of a line can be rewritten in the form of y equals mx plus b, where m is the slope and b is the y-intercept, what I want you to do is try your turn 1. So you have a line with 2 points labeled on it, -8,5 and 0,2. You're to do 2 things. You want to calculate the slope of the line, and you want to then determine its equation by plugging things in appropriate into this equation here. All right, go ahead and see what you get. Remember to pause the video with your turns, try them, and then unpause it to see the solution. All right, so if you tried that, again, you can subtract the y's and the x's in either order, doesn't matter. I chose to subtract 2 minus 5 and 0 minus -8. And so what we find is that the slope, the m is 3/8. And the equation of the line for part 2, well, all we need, if we're using this form, all we yet need is the b, which is the y value of the y-intercept if you happen to have that in hand. But we do. The y-intercept is 0,2, and so the b happens to be 2. And so if you just plug in m equals 3/8 and b equals 2 into this equation, you get the slope-intercept form of the line. Not too bad. All right, let's try this one. So example 3, now we actually give you the slope of the line. You don't even have to compute that, but we don't give you the y-intercept. Rather, we give you a point that's on the line, namely 310. And what we want you to do is write the equation of the line in slope-intercept form. All right, so you can be given different information about a line that uniquely defines it. And here is a different sort of situation. So what I want to do is recall the definition of a slope, right? I have a point, I have 3/10, or sorry, 3,10 on the line. I do not have a second point in hand, so let's just call another point on the line xy, right? We're assuming that this point is on the line, and if it is, we know that if I use the slope formula, change in y over change in x, with these 2 points, I have to get the ratio of 2, right? That's the definition. Remember, any 2 points on the line yield the exact same slope. All right, and so let's do that. Let's subtract the y's to get y minus 10, over subtract the x's to get x minus 3. That ratio has to be 2. Well, now you say, well, so what? What am I supposed to do? Well, that's an equation involving y and x. So what you have to do is solve it for y in terms of x. Right? How do you do that? Well, it's a fraction in there. Get rid of the fraction. Multiply both sides by the denominator that occurs, namely x minus 3. Right? So that's what I do here. It gets rid of it on the left side and essentially then moves it to the right. Right? So you have this linear equation in terms of y and x. I want to make it look like y on one side, so I'll take the 10 over to the right. But I want the right side to be of the form mx plus b, right? A number times x plus another number. And so all you have to do is simplify, right, this plus 10. So distribute the 2 to get 2x minus 6, then plus your 10, and then add those constants. If you do that, you get y equals 2x plus 4. Right, this is the slope-intercept form of the line that satisfies these 2 conditions. All right, so you'll say, well, that's awful painful. And why would you bother going through that if you already have an equation here? Why not just stop there? And I couldn't agree more, right? In fact, that's actually given a name. It's called the point-slope form for the equation of a line, right? This is the same exact thing as this. The only difference is how it looks, right? This is a simplified version of that equation, but these 2 mean exactly the same thing. They tell you point for point exactly the same information. So I almost would prefer you leaving it like this, but other courses and whatnot where you bump into it will actually use both. In fact, probably even this more. So I'm going to have you get used to both forms of the equation. All right, go ahead and try this your turn. You want to find the equation of a line that has the slope passing through that point. So you're going to emulate what we just did in that example to solve this. See what you get. Okay, so if you use the point slope formula with another point xy on the line, remember, you subtract the y's, so y minus 20 over subtract the x's, x minus a negative 8. That ratio needs to be minus 3/4. So you have this guy, and you can even rewrite that. There's no reason for the double negative. Just write the bottom as x plus 8. Now you want to move the x plus 8 over, so I'm going to multiply both sides by x plus 8. That gets rid of it on the left and just moves it over as a multiple on the right. This right here is the point slope form of the line, but remember we wanted the slope-intercept form, and so what do we have to do? Multiply through by the minus 3/4, both those terms. That's what I get on the right side here, and then add your 20 to both sides. The end result here is what you get. That's the slope-intercept form. All right, oops. Let's go to your turn 3. Now it's another type of characterization for a line. We know from geometry that two distinct points uniquely determine a line. And so what that means is that if I know that these 2 points lie in that line, I should be able to deduce what the equation is without any problem. Right? So that's what I wanted you to try to do. Try to go ahead and find the equation of that line that passes through those 2 points, see what you get, and we'll talk about that when you give it an attempt. Okay, so first things first, I have to find a slope, right? You want to make sure that you can emulate something that we've already done. That would be a good approach. And so in all of the examples we've done so far, we've had a slope in hand. And so what we're going to do is we're going to find the slope between these 2 points using the same definition, change in the y over the change in the x. If you do that carefully, you'll get 6 over 7. Well, now we have a point. In fact, you have a choice of which either one you want to use. It doesn't matter. I just chose to use this one. Doesn't matter though. So, and I have a slope, right? So think of this as x1, y1, and this is your slope m. Use that previous approach in example, or your turn 2, to find that the point slope form for the equation of the line is this guy. Distribute the 6/7 through, and then subtract your 6 to get the slope-intercept form. Okay. All right. So if you have 2 points on a line, a point and a slope, a y-intercept and a slope, given all that different types of ways of prescribing or describing a line, you can find the equation. Now there are other things you can have instead, right? You have to have information about the slope somehow, be it by 2 points or just having it outright. But what you could always do is compare one line to another, and you might be able to gain information about the slopes in that way. Right? So one way to do that would be to know that if you know that a given line is parallel to another one, remember from geometry, parallel meant they never touched. Well, if they don't touch, the lines had better have the same slope. Otherwise, one's eventually going to bend faster than the other, and I don't care how long it takes, ultimately they will intersect, and that would be contrary to the fact that they're parallel. Right, so what we'll define 2 lines to be is parallel if their slopes are exactly the same. This one here I cannot prove until we get to geometry, or not geometry, trigonometry rather, but we'll just use it as it is. We'll say that 2 lines are perpendicular if their slopes are negative reciprocals of each other. Right, so for example, if a line had slope 2 and you said that another line was perpendicular to it, the slope of that line would have to be negative 1 over 2. It's the negative of the reciprocal of the slope you already have. Same way, if you know your line has a slope of negative 4/3, then any line perpendicular to it would have to have a slope of positive 3/4. It's always the negative of the reciprocal of the slope that you have. If that's the case, the two lines intersect in a 90-degree angle, which means they're perpendicular. Okay, so let's look at example 4. Suppose you want to find the equation of a line that is perpendicular to this line, and you know that it passes through this point. Okay. Well, again, we have a point. Perfect. So all we need now is information about the slope, and we can emulate what we did back in your turn 2. Well, we know that it's the line that you're trying to find the equation of is perpendicular to this guy. Well, the slope of this one, since it's already in slope-intercept form, the slope of this line is 3/4. And so if the line that we're after is perpendicular to it, its slope must be the negative reciprocal of that guy. So namely -4/3. Okay, so there's your slope. There's our point. So plug them in and follow the same exact thing that we did back in your turn 2 with taking another point xy on the line, going through that same exact process, and that will yield this equation. This is the point slope form, right, of the equation of the line, and this is the slope-intercept form. Both are acceptable unless I ask for a particular one, which I will do because I want to make sure that you're familiar with both. All right. Now, not always, so if I give you two lines, they need not be parallel or perpendicular, right? They could intersect in other angles, per se. And so what we want to do is find the point of intersection of two lines. Oftentimes that's of interest when we're solving word problems or whatnot. And it really amounts to solving a system of two equations, but graphically. All right, so let's, for example, what if I wanted to find the intersection point of these two lines? Okay. Well, the first thing to note is that this line here, the slope, if you were to distribute the 3 to both terms, the coefficient of the x would be 1/3. The coefficient of this x is 2. Being that they're both in slope-intercept form, the slope of the first one is 1/3. The slope of this guy is 2. In other words, the slopes are different, and so the lines are not parallel. Furthermore, the lines don't have slopes that are negative reciprocals because they're both positive, right? And so they're not perpendicular either. But they do intersect. If they're not parallel, they're going to intersect, and albeit not at a 90-degree angle. What I'm interested in is the actual point, the point x comma y, whatever that is, where they actually intersect. Well, the only way that happens is if the point xy is on both lines. And so what that means is you have to solve this system of two linear equations, right? That has to happen, and this has to happen in order for the point of intersection to be on both lines. And so what you want to do here, it's crying out to use substitution because you already have solved both of them for y. And so what I do is I substitute this expression in for y in the second equation. That yields this equation here, which is linear. So how do we solve linear equations? Well, if they involve fractions like we do here, get rid of the fraction, multiply both sides by 3, then simplify the right side, right? Distribute that 3 through to get 6x minus 18. And then you want to get the x's on one side, constants on the other, like we always have done. And so doing that gives you an x value of 4. But remember, I want the point. And so to find the y coordinate, I put this x equal to 4 back into either of these equations. Doesn't matter which one, because it has to give you the same y value for both. And so if you do that, if I put it in here, 2 times 4 is 8, minus 6 is 2. The y value of interest is 2. And so we know the point of intersection of these two lines is the point 4, 2. And you can actually see that illustrated in this picture here. All right, go ahead and try finding the intersection point of these two lines here. Same idea, you're going to have to solve a system of equations, but you don't necessarily have to use substitution to do it, right? You could technically use elimination. Your choice, but see what happens. All right, so I kind of gave that away a little bit. You do want to, in my opinion, elimination is the more sensible of the two approaches because if you simply add the equations together, the x drops out immediately, right? So there's no reason to go ahead and solve this guy for y, plug it in, and chug through that. The x's just cancel out. And so if you add the lefts and add the rights, you get y equals 4 immediately, and then just plug in y equals 4 into either of these equations. Well, let's say this one, and that'll give you, if you were to solve this equation for x, that gives you x equals -3. And so the point of intersection of these two lines is the point -3, 4. All right, so go ahead and try these out. You'll notice here that there, depending on what version of the manual you have, there might be a gap in the numbering. That's just a typo. There's nothing missing. Don't worry about your missing 6 through 10 if you happen to be. It's just a numbering issue that I had. So sorry about that. But go ahead and try these problems out for homework and see how they go. Let me know. Okay, bye.